In example 4, we're going to look to create an equation given the graph of an exponential growth or an exponential decay function. So if we take a look at letter A, the first thing I want you to notice is as you go from the left to the right, your graph is going up, which indicates to you that you have an exponential growth function, meaning your base should be a number that is bigger than 1. Now, as we try to complete this, we're going to do something very similar to the last example in example 3. So we're going to create our table. As we create our table, we want to move from the left to the right. So we're going to take the points farthest to the left and then move to the right. They have to go in order. That's the important part, or your base is going to end up being incorrect. So the point farthest to the left is the point 0, 1. And then the next point that we have is the point 1, 5. All you really need are 2 points in order to determine what the base is going to be. And then just like we did with the tables above, we are going to take and divide. Take the one farthest down and divide it by the one above. So we have 5 divided by 1, which is 5, which tells us that our equation is y equals 5 to the x. Now, if we take a look at letter B, it's slightly different than what we did in letter A. As you see your graph, it goes up from left to right, so we know that it's going to be an exponential growth function. But our asymptote is no longer here at 0, where it was in letter A. So if you think back to when we were graphing these, remember that number that was added or subtracted outside of our function. So if we take a look at something like y equals a to the x plus d, remember this d value indicated what our asymptote was. And so in this one, because we don't have anything added on, it indicates that we just have an asymptote at 0. Well, this one, it does have something that's not at 0. And so what we want to look at first is where is that asymptote? And so you can see your graph is headed towards -4. So we know that in our function, we have to have a -4 at the end of our equation. But what we need to do is we need to find out what that base is. So to do that, we need to move our points back to the beginning. So for instance, all these points were moved down 4 along with this asymptote. So we're going to do the opposite and move them back up again. So we're going to take at this point 0, -3 and go up 4. 1, 2, 3, 4 at the 1. And then we'll take our other point, which is at 1, -1, move that up 4. 1, 2, 3, 4. And we get this point right here. And again, we only need 2 points. So now we can create our table of values. Moving from the left to the right, our first point is 0, 1. And then our second point is 1, 3. So if we divide these out, 3 divided by 1 is equal to 3. So our equation is going to be y equals 3 to the x. And then remember what we did is our asymptote is down here at -4, so we have a -4 at the end of it. Next, I would like you to pause it and do the try this. Unpause it if you're ready to check your answers. If you did the try this correctly, what I want you to notice is that your graph was moved up to 2, so you know that you're going to add 2 on the end of it. So your answer here is y equals 1/2 to the x plus 2. If you have questions on how I got that, please let me know and I'll explain it to you.